Welcome to the last page, and it looks like I'm cutting it real short to class time. But we'll go ahead and solve this. Determine the form of a particular solution of the given differential equation. So again, the first thing you want to do, here we're just trying to find the form of the particular solution. So we're just setting it up. We're not actually finding the particular solution. We just want to know the form, all right? Because this one's a long one when we do it. And so we're just going to find the form. So we're just going to work on, making sure that any of those repeated values, we're taking care of those correctly. So the first thing, again, is solve for the homogeneous part, find the complementary solution. So we set it equal to 0. We group the first two terms, group the last two terms, pull out m squared and minus 4. We get m minus 1, m plus 2, m minus 2. So our complementary solution is y sub c equals e sub c sub 1 e to the x plus c sub 2 e to the 2x plus c sub 3 e to the negative 2x. All right, now, when I look over here, I notice, okay, I have a constant. So that's just going to be a. The next one's going to be negative e to the x. So it's just going to be plus. So there, my next function is e to the x. So then it's going to be plus b e to the x. And then I have another function here, e to the 2x. So that's just going to be c e to the 2x. All right. Now, again, I'm not worried about these plus or minus signs because a, b, and c, they're constants. All right. Or not, they're coefficients, so they could be positive, they could be negative. So now I'm going to look at my complementary solution and see if anything repeats. Do I have an e to the x? Yes, I do. So what I'm going to do is, well, then that needs to be b x e to the x. So that's taken care of. Do I have an e to the 2x? Yes, I do have an e to the 2x. So I'm going to make sure that since that's repeated, that's taken care of. So it's going to be cx e to the 2x. And I'm finished. All right. Because now there's not going to be anything that is going to repeat. All right. So that's it for that. And now I'm going to go ahead and do example 6. Determine the form of a particular solution of the given differential equation. So again, we're just looking for the form of the particular solution. All right. So here we have a fourth order linear differential equation. So we're going to solve for the particular solution first. So we set it equal to 0. We get m squared equals 0, and m squared minus 1 equals 0. So I have a 0 of multiplicity 2. So there's two solutions with 0. So then it's going to be c sub 1 e to the 0x plus c sub 2 x e to the 0x. So if you have a solution of 0, it's okay. You're just going to put a 0 in for there. That means that, when you solve for that, you're going to have a c sub 1 and a c sub 2x. Okay? All right. And then over here on the... So we have 1 and a minus 1, so that's e to the x and e to the negative 2. E to the negative x. All right? So now, let's look over to find our particular solution. We have 4x, so that's going to need to be taken care of ax plus b. And I can put those in parentheses because that takes care of the linear part. Plus a linear times an exponential, so plus cx plus d, and then times the exponential e to the negative x. All right, now, what I notice here is that I have an ax plus b already. So what if I multiplied by x? Let's see if that would take care of it. If I multiplied by x, multiply that through, I'd get ax squared plus bx. Well, ax squared's good, but I already have a bx. That's c sub 2x. So then what I had to multiply that by is an x squared. So when I multiply that in, I get ax squared plus bx. So, whoa, ax cubed plus bx squared. I'm sorry for that 3 or 4 seconds of what was I doing. All right, and then over here when I distribute cx e to the negative x, I have an e to the x, but it's only a constant. Oh, but when I multiply by that d, I'm going to get that. So what I'm going to multiply by is an x. When I do that, I should have cx squared plus dx. If I do that, will I have anything repeated? Let's see. Nope, I won't. And so this is my solution. And so, what I would do to write this out and keep everything. I'm just going to erase this whole thing and then write out what it would be. It would be y sub p is going to be ax cubed plus bx squared plus cx squared plus dx times e to the negative x. And that takes care of everything. Because I already have a linear, so I had to make sure that I multiply that by an x squared. I already had an e to the negative x, so multiply that by x. All right.